Hello everyone, welcome to my YouTube channel Zenith GATE Mechanical. Continuation with the concept and question series, I am going to discuss some of the important problem. But for solving these problem, you have to know these three things. The first one is how to draw the free body diagram, and the second one is how to calculate the reaction at the supports, and the third one is how to use the Lami's theorem. Okay, so all these things I have discussed in my previous session. So those who have not watched these lectures, so please go through that one before coming to the this particular session. So what is the question? A man whose weight 600 Newton stand on a horizontal beam of negligible weight at C and hold a string which is passing over two smooth pulley and attached to the point B. The tension in the string is, so there are the four options which is given. Now a man whose weight is given, and these are the string which is passes over the pulley, and this end of the string is which is connected to this particular beam at the point B. So you have to calculate what will be the tension in this particular string. Okay, so you have to draw first of all the free body diagram of this man as well as the free body diagram of this beam. So this is the man. Now I am denoting the weight which is acting downward, and there will be a tension force on the string. This man is making a contact at point C. That means there will be one normal reaction here. So here will be one normal reaction, which is nothing but N. So now, if you consider the free body diagram of this man, consider free body diagram of man. So if you write summation of force in the y direction 0, that means this is the y direction and this is the x direction. So tension plus N is equal to W. So can I write the normal reaction will be 600 minus T, where W is nothing but the 600 Newton. That is nothing but the weight of the man. Okay, so this is the first equation. Now you will draw the free body diagram of this beam. So same normal reaction will act here. Now you can see here what are the forces. One normal reaction, another is the tension, and there will be two reaction at this point because it is a hinge joint. Okay, but there is no horizontal force which is acting on this beam, so the horizontal reaction will be 0. So let me first of all write down what are the reaction which is acting at this point. So RAV, this is RA horizontal, and one another force which is nothing but the tension at B point. This distance is given as 2 meter. This is also given as 2 meter. Okay. So if you take the summation of moment about A, summation of moment about A is equal to 0. Okay. So the tension into 2, that means I'm taking the moment about this A point. So force into this perpendicular distance, which is creating an anti-clockwise, is equal to N into 4, which is creating a clockwise movement. So anti-clockwise is equal to clockwise, or you can write T into 2 minus N into 4 is equal to 0. So once you will take this value in the right hand side, then it will become positive. Okay, so the tension value is nothing but 2N. So if tension is 2N, so can I calculate what is the value of normal reaction from the first equation? Okay, so what you will do, you just put the value of either the normal reaction in terms of T or the value of tension in the form of normal reaction. So N is equal to 600 minus T, which is the first equation. Can I write N is equal to 600 minus, what is the T value? 2N. That means the normal reaction is nothing but 200. If normal reaction is 200, can I calculate what is the value of tension from first? Yes. So the tension value is nothing but 600 minus 200, which is equal to 400 Newton. And that you have to find out. Tension in the string, which is nothing but 400 Newton. which is coming into this particular problem. Okay, so what will be the correct answer? The option B is the correct answer. So option B is the correct answer. Now move to the next question, a little bit tricky question. A thin ring of mass 2 kg. Okay, so the mass of ring is given as 2 kg and the radius is given as 140 mm, is held against a frictionless wall. Okay, there is no friction, by a 125 millimeter string AB. So this distance is given. That means the length of a string. Determine the distance. This distance you have to calculate. And the tension in the string. What is the tension in the string? And the reaction at the C. Because it is making a contact at the C point. So there will be one normal reaction. Okay. So for solving this particular problem, again you have to draw the free body diagram. So that's why I'm telling, if you have a thorough understanding how to draw the free body diagram, so 90% of the problem will be done. So I will take this ring and I will apply what are the forces which is acting on this ring. One is the tension force. One is the tension force. And another will be the normal reaction at C. So let us suppose this is NC. And here will be weight of this body, which is the center point only. Weight of this body, which is nothing but W. And it is given as 2 kg. Weight of the body is 2 kg, means this is mass is given as 2 kg. So 2 into G, which is nothing but 2 into 9.81, which is 19.62 Newton. So the weight of the ring we have calculated, which is nothing but 19.6. Now you have to calculate the value of this D. So what you will do, first of all, you will use the geometry. So this is the point A, this is B. So let us suppose this point is center of gravity G and this is C. So can I write this D value, which is nothing but AC is equal to AG square minus GC square of the square root by using Pythagoras theorem. What is the AG square value? AG square is nothing but this is 125 and this is 140. So this will be 265. So 265 square minus GC value is the radius of ring only. That means 140 square. So once you will solve the D value, which is nothing but 225 mm. 225 mm. So the first part of this question is nothing but D is equal to 225 millimeter. Now you have to calculate the tension in the string and the reaction at the C. Now, once you will use the Lami's theorem, because only three forces are acting, so you can calculate the normal reaction as well as the tension. So now I am going to use the Lami's theorem. So I will draw what are the forces acting at the G. One is the W, which is nothing but 19.62 Newton. And here will be one normal reaction C. And this is nothing but the tension T. Tension T. So the tension T and the NC value you have to calculate, but one force is known to you, which is weight of this ring. Okay. Now, once you calculate the angle of this tension in the string with the horizontal, your problem will be solved. So for that, you can use this particular triangle. Let us suppose this is the theta angle in triangle ACG. So what is the value of cos theta? Cos theta is base, that is GC, divided by hypotenuse, that is AG. GC is 140 and this is 265. So from here you will get the value of theta. So what is the value of theta? 58.109 degree. Okay. So that means with this horizontal axis, the tension is making 58.109. Now I can use the Lami's theorem. So Lami's theorem, T divided by sine of 90 degree. Okay, because NC and W are making an angle of 90 degree. Now NC can be written as sine of 90 plus 58.109 and 19.62, which is the weight of this ring, divided by sine of 180 minus 58.109. So from here you can calculate the tension as well as normal reaction. So tension is 19.62 divided by sine of 180 minus 58.109, which is equal to 23.108 Newton. Okay, so the tension value you have calculated 13 tension value you have calculated 23.108. Now similarly NC value is 19.62 divided by sine of 180 minus 58.109 into sine of 90 plus 58.109. So let me calculate this value. So you will get 12.21. So the NC value, once you will solve, you will get 12.21 Newton. Okay. So all the three parts I have covered in the same problem. You have calculated the distance d and what is the tension in the string and what will be the normal reaction at the point of contact. Okay. Now move to the next question. A cylinder of radius 250 mm and weight is 10 kilonewton is rolled up an obstacle of height 50 mm by applying a horizontal force which is acting at the center. All interfaces are assumed to be frictionless and the minimum value of P is. Okay. So whatever the questions which I have discussed, some of the problem which was already asked in the GATE exam. Okay. Now again, you have to draw the free body diagram. So this is basically a cylinder. Here will be the B point. This is nothing but W. Here is the P force which is acting. Now it is making a contact, so there will be a normal reaction. Let us suppose NA at this A point. So this is O point. So let us suppose this is angle theta and this is D point. So can I calculate this theta value? So cos theta is nothing but base by hypotenuse means OD by OA. OA is the radius of this cylinder. That means this value is 250 and OD value is this distance is given as 50 mm. So what is this value? This value is 200. So this is nothing but 200. So from here you will get the theta values 36.86 degree. Okay, so you have calculated 36.86 degree theta. Now the problem is very simple. Again, you have to consider the point O and just apply the forces. This is the P force. Here will be 10 kilonewton force which is acting downward. And here will be one normal reaction NA. And this angle you have calculated theta. Again, if you use the Lami's theorem, what is Lami's theorem? NA divided by sine of 90 is equal to P divided by sine of 180 minus 36.86 is equal to 10 divided by sine of 90 plus 36.86. So from here you will get the value of P. Just equate these two terms. So you will get the P value, which is nothing but 7.5 kilonewton. So what will be the correct answer for this question? Option D is the correct answer. I hope this series truly help you in your exam preparation. So don't forget to like, share, and subscribe. Thank you so much.